When bears and ground squirrels hibernate in winter, they stop eating, lasting until spring simply on the fat reserves they've stored up in their bodies. Usually, this sort of prolonged fasting and inactivity would significantly reduce the mass and function of muscle, but hibernators don't suffer this fate. How they avoid it, however, has been a mystery. Now, in research published in Science, an Université de Montréal biologist has figured out why, and his findings could have implications for, of all things, the future of space travel. By studying a variety called the 13-lined ground squirrel that is common in North America, Matthew Regan has confirmed a theory known as urea-nitrogen salvage, dating back to the 1980s. How could this discovery be of use in space? Theoretically, Regan posits, by helping astronauts minimize their own muscle loss problems caused by microgravity-induced suppression of protein synthesis and which they now try to reduce by intensively exercising. Because we know which muscle proteins are suppressed during spaceflight, we can compare these proteins with those that are enhanced by urea-nitrogen salvage during hibernation, said Regan, who carried out this research while a postdoc at the University of Wisconsin-Madison. He is now continuing his work through a Canadian Space Agency research grant at UDM, where he last year took up a position as assistant professor of animal physiology in the Department of Biological Sciences. To do that, in their lab they injected their test squirrel's blood with, double-labeled, urea, meaning the urea's carbon atom was 13C instead of the usual 12C, and its nitrogen atoms were 15N instead of the usual 14N. That process, they found, led from the initial transport of urea from the blood into the gut, to the breakdown of urea into its component parts by gut microbes, to the flow of substances, called metabolites, containing urea-nitrogen back into the animal, and finally to the eventual appearance of T. He did his experiments on squirrels with and without gut microbiomes at 3 times of the year: summer, when they were active and not hibernating; early winter, when they were 1 month into fasting and hibernation; and late winter, when they were 4 months into fasting and hibernation. Clear evidence of nitrogen salvage. What they found was definitive. At each step of the process, there was clear evidence of urea-nitrogen salvage by the squirrels with intact gut microbiomes. Importantly, the squirrels with depleted gut microbiomes displayed no evidence of urea-nitrogen salvage at any step, confirming this process was wholly dependent on the gut microbes' ability to degrade urea, something the squirrels themselves cannot do. Second, there was evidence the microbes themselves were using the urea-nitrogen to build their own new proteins, which is useful for them because they, like the squirrel, are under conditions of fasting hibernation. Thus, both the squirrel and its microbes benefit from urea-nitrogen salvage, which makes this process a true symbiosis. What this means, Regan said, is that the squirrels emerge from hibernation in the spring in good shape. This is important because the year's only mating season, which is a time of intense physical activity for both males and females, occurs directly after they emerge from hibernation. Urea-nitrogen salvage may therefore enhance the animal's overall biological fitness, starving masses and the elderly beyond the implications for space travel and the health of astronauts. Regan's discovery could have more immediate impacts now right here on Earth, in the starving masses of the U. Hundreds of millions of people globally experience muscle wasting as a consequence of various conditions. Undernourishment, for instance, affects over 805 million people globally. The mechanisms that mammals like the 13-lined ground squirrel have naturally evolved to maintain protein balance in their own nitrogen-limited situations may inform strategies for maximizing the health of other nitrogen-limited animals, including humans, said Regan. One solution might be to develop a pre- or probiotic pill that people could take to promote a gut microbiome of the kind that hibernators like squirrels have. To be clear, these applications, though theoretically possible, are a long way from delivery, and a lot of additional work is needed to translate this naturally evolved mechanism safely and effectively to humans, Regan said. But one thing I find encouraging is that a study from the early 1990s provided some evidence that humans are capable of recycling small amounts of urea-nitrogen via this same process. This suggests that the necessary machinery is in place. It just needs to be optimized. Matthew D. Regan, Edna Chang, Yunxi Liu, Marco Tonelli, Kristen M. Verdorn, Sadie R. Google, Garrett Soon, Hannah V. Carey, Fariba M. Asadi Porter. What wintering squirrels can teach astronauts. The unique way that ground squirrels burn almost no energy when they hibernate, with no loss of muscle mass, has implications for space travel. Science Daily. What wintering squirrels can teach astronauts. The unique way that ground squirrels burn almost no energy when they hibernate, with no loss of muscle mass, has implications for space travel. What wintering squirrels can teach astronauts. The unique way that ground squirrels burn almost no energy when they hibernate, with no loss of muscle mass, has implications for space travel. Science Daily. https://ift. TT, 3 GC Wills, accessed January 27, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.